Clear what?
Asteroid field. So full steam ahead. Full steam ahead. We're good. We're good. We're
going as fast as we can. Right?
Woo! Oh! I got a phone call. Throw it down.
Got it. Okay.
Hello. Hey, Mr. President. How you doing, sir? Yes, sir. I'm flying the $1 million space probe that you have for us. Yes, sir. We're going to Jupiter. Yes, sir. Flux capacitor. Yes, sir. I'd love to go get one with you today. Yes, sir.
Yes, hello.
Good talking to you, sir. I'll see you soon.
Mr. Rollins? Oh, well, we're on the air. Drew, we're on the air.
Oh God. Put this thing in stop.
Okay.
Okay.
Good morning, and welcome to another episode of Science Content Network. I'm Tim Tully.
And I am a $1 billion space probe pilot, Drew Bolinger.
Today's topic is space.
Space.
And the measurements that we use to measure distance. Unlike here on Earth, the unit of measurement to measure a distance isn't so nice and easy to read.
Definitely not.
If we would go to a friend's house, we might travel a few miles.
Yep, couple blocks.
If we were to go to a neighboring planet, star, or galaxy, the numbers would get really, really big.
That's right, Tim. First, we should probably look at our neighborhood in space. Let's look at the distance between the Sun and the Earth. This is called 1 astronomical unit, or 1.5 times 10 to the 11th meters. This is a standard unit of measurement for within our solar system. If we would look at a planet inside our orbit or closer to the Sun, we see Mercury is 0.387 AUs.
It certainly is.
It is. But if we look at Jupiter, which is much farther out in orbit from us, from the Sun, we see it as 5.2 or 5 times the distance Earth is from the Sun.
Excellent point.
So Tim, to look outside our solar system, we should probably take a closer look at something else here.
Yeah, we really need to do that. If we were going to the nearest star, we definitely don't want to use AUs.
Nope.
Proxima Centauri is 27,000 AUs from our Sun.
Yep, a lot of AUs.
So we want to use a nicer unit of measurement. Outside the solar system, we use light years. This is the distance that light travels in a year. Proxima Centauri is 4.3 light years from Earth. That means it takes light just over 4 years to travel from Proxima Centauri to us. The speed of light for traveling for a year would go 9.5 trillion, that's trillion, kilometers per year, or 300 million meters per second.
That's its speed.
That's fast.
Much faster. When we look at Proxima Centauri out in space at night,
right,
we actually are looking at it 4 years ago. That
really
means today what it looks like now is what it looked like 4 years ago. Now we know our universe is somewhere between 13 to 15 billion years old.
Yes.
And some of the oldest stars and galaxies that we can see, we've seen about 13 billion light years away from Earth. That means what they look like at the creation of our universe is what we're seeing just right now.
That's mind-blowing. That's amazing.
It is. It is.
That's amazing. So, Drew, you tripped to Aries last week.
Well,
what was going on with that?
You know, it was awesome. You know, I put it in full throttle, got the spaceship going and everything, got the flux capacitor. Wait a second. Yes, Mr. President. Yeah, you got, sir. Yes, sir, I got my throttle man right here. He can take over on the space probe. Yes, sir, no problem, sir. I'll be ready to go. 2 seconds, you got it. Tim, relax. Use the force, Tim. Use
Just a throttle man, and he's got me being a pilot.
Don't hit me, the president, Tim.
I'm trying. Where is he?
Use the force.
It's funny you should say that, because next week's episode is on forces.